Smirnoff Ice knows summer comes with all sorts of questions. Like, is it okay to drop everything the second the sun comes out and enjoy the day? For your summer vibe, choose Smirnoff Ice, Red, White, and Berry. And for flavor with no compromise, choose Smirnoff Ice, Red, White, and Berry Zero Sugar. Take some home today. Available at most retailers. Our advice, choose Smirnoff Ice. Please drink responsibly.
Smirnoff Ice Premium Flavored Malt Beverage. The Smirnoff Company, New York, New York. And Smirnoff Ice Zero Sugar Original Premium Flavored Malt Beverage. The Smirnoff Company, New York, New York.
Hey, everybody, and welcome to another episode of JavaScript Jabber. This week on our panel, we have Amy Knight.
Hey, from Nashville.
Dan Shapir.
Coming at you from the very hot Tel Aviv.
Steve Edwards.
Hello from sunny Portland.
I'm Charles Max Wood from devchat.tv. And I just have to say, Dan, you said hot Tel Aviv, and you were talking about how it might get up to 80. It's already 80, and it's 10:30 in the morning. So
I said it got up to 90.
90. Oh, wow.
80 is like springtime or fall. It's, we're summer here.
And just to clarify, that's 80 Fahrenheit, not Celsius, right?
Yeah, although sometimes it's
80 Celsius is 200.
Yeah.
Boiling, yeah.
Yeah.
Anyway, we have a special guest this week, and that's Joe Karlsson. Joe, welcome back.
Yo! Hey, what's up? I'm coming from Minneapolis. It's nice and cool. And I was just going to say, it's not the heat that gets you, it's the humidity.
And the mosquitoes, right?
And the mosquitoes, absolutely.
And Tel Aviv can get pretty humid as well, just so you know.
I was a missionary in Italy for 2 years, and I remember one August, the whole month was like 105 degrees and 100% humidity, and you would just walk outside and just melt on the sidewalk. So I hear you.
Well, what you do is you walk outside and then you walk straight back in again.
That's right.
That's easy in quarantine too. We're just staying inside anyways.
Yeah, fair enough.
One of my favorite communities in programming these days is the Angular community. Every time I go to an Angular conference or meet up with some of my friends who are in the Angular community, I have a great time, and a lot of them have wound up on Adventures in Angular. So if you're doing front-end development, you're looking for a way to keep current on the Angular ecosystem, and you want to have a good time listening to fun people talk about great topics related to Angular, then go check out Adventures in Angular at adventuresinangular.com.
So we have you on to talk about MongoDB schema design. And I have to preface this a little bit by saying that I have never actually done this right, or at least maybe I did it right and I just wasn't happy with it. But I've tried using MongoDB a few times, and, it's like, okay, well, how many of these things do I put in the different collections? And, how do I set this up to work? And maybe it's just because I have SQL brain damage or something else, or I'm trying to make it, it's like trying to write
SQL
Ruby
home
and
syndrome.
JavaScript.
Yeah. No, I think that's super common. And that's what I want to discuss here too. It's like one of the most misunderstood and like misused things. And I think designing like a schema that's going to be scalable and durable and last a long time, I think is hard to do.
Yeah, but Joe, it's schemaless, right?
What's a flexible schema? Yeah, exactly. No, totally. Yeah.
I thought we were going to talk about modeling, and I had all my jokes about modeling and how Joe looks like Fabio and everything, but I guess we'll talk schema instead.
That's a great podcast joke, because everyone could see my long, luscious hair right now. No, I love it.
In this podcast, if you have hair, you're already ahead.
Ahead, no pun intended, right?
I have hair. I haven't shaved in almost a week, so my chin is...
It looks great on you.
Yeah, thanks. Makes me more sophisticated.
Yeah. I should mention too, I work for MongoDB. I'm a developer advocate and software engineer. And I think I come from a lot of these perspectives too. Honestly, like before I started working for MongoDB, I didn't really understand the stuff either. And now that I'm here, obviously I'm working with it every single day, which helps kind of understand it a little bit better. But I think these are all super common, like criticisms and places to be, coming to MongoDB. Hopefully someone will learn something from this podcast today. That's the goal.
Given my knowledge level, that's almost a given.
I prefer everyone's their knowledge levels to be super low, because it makes my job way easier. So that's great. Thank you for that. No one's going to ask any hard questions today. That's great. But if you're like new to it, or you've been using MongoDB forever, or if you've never even used it and you're like thinking about it, like I'm hoping that we can like unlearn some of your SQL brain damage, or like get you set off in the right spot from the beginning. That's the goal here today.
Yeah.
So this feels like deja vu. Was this the episode that we didn't record?
No.
Oh.
Last time we did like just an intro to MongoDB.
Oh, okay.
And this time it's like, so this is like a little bit more. Yeah. So I was on last. If you've missed that episode, it's a great place to start if you're just brand new to it too. And this is like 102. This is like lesson 102, right? We're like one level up here.
Excellent. I love being one level up. Amy has a question to start.
I do. So I was actually talking to somebody about this the other day, so I feel like maybe it's a good place to start. But I feel like most people kind of know the difference between like NoSQL and SQL.
Yeah.
But it's my understanding like there are different types of NoSQL options.
Yeah.
So can you explain the difference between like MongoDB and Cassandra or like any of these other options? I think isn't Cassandra document based, but there's others too. There's like Graph and stuff like that. So explain to us the different NoSQL options.
Yeah, that's a great. Yeah, so I think that's a great place to start. Like, what is NoSQL and what is MongoDB? I love that. So let's just start. I guess NoSQL. This is controversial. I think it stands for not only SQL. There's some fights about what that actually is, but you're right. There's a bunch of different, and it basically is any database that's not a traditional RDBMS or relational database management system, which we traditionally think of SQL. But yeah, that includes things like document-based databases, which MongoDB is, and documents basically mean like it's like a JSON-like document. We actually call it BSON. It's binary instead of JavaScript. But yeah, you just save things like you would an object in memory, you can save that in a database. Or there's things like key value pairs. That'd be something like Redis. So you just, instead of having like more deeply nested data structures, like you can have an object, you retrieve things really quickly just from key value pairs. It's very flat. And then graph databases like Neo4j, those are things that are great for like, social graphs or like kind of connecting things with more complex connections. Think of like a social network, like your friend graph or whatever. I'm missing a couple here. What else am I missing here? Team, what else is NoSQL database?
Well,
Did we just say
Cassandra is
Graph?
columnar.
You're right, I think.
Yes. Yeah. What's an example?
The way
of
they
that?
think about data is different than it's not documents. I haven't used it in a long time.
Both Mongo and Postgres are something that you use typically for applications where you have users.
Yes.
Cassandra is odd in that it's used for an application where there's users, because that sort of database, the column database, is typically used for data warehousing, which is for statistical analysis of large swaths of things. Then you've got things like Neo4j that are object databases, which are typically for things like desktop applications where you want persistence of the memory state. Actually, I shouldn't say that. I don't know if that's actually what it's for. That's just what I thought of it as. But you can rehydrate an application. I think it has server side aspects, but it's when you want to be able to rehydrate something in memory, almost like a sleep mode. Something goes to sleep, something wakes up, and everything's still there. Then you've got document databases, which are not used by, but perfectly great for something like Wikipedia. Are there other mainstream databases, types of databases that I didn't mention there? Because I think we do tend to lump everything into NoSQL, but it's like everything from enterprise class data warehousing to Mongo is NoSQL, and that's quite a wide range.
I do know that sometimes when people talk about NoSQL, what they actually mean is that they're using a SQL database, but they just have data like a table with one value, and they just store JSON into it, and like it's a blob.
Yeah, so, like that's a great feature of Postgres, and I think that MariaDB, the original MySQL, has integrated that, if I recall correctly.
I believe they have to. Yep, I think they have to.
And you can easily do it in SQLite, but SQLite doesn't specifically support querying by JSON types, whereas Postgres and I believe MariaDB do. I know that Postgres does, but Postgres has two different JSON types.
And there's different use cases for using it. Like all of them have like different special features or things you might want to use those for. But typically, I think NoSQL would think of like more highly performant or like different forms of availability. Like MongoDB, we have like shardings. You can like split it up differently, horizontally scale it as opposed to vertically scaling a database. And sometimes there's flexibility with your schemas or whatever, right? I think with a traditional SQL database, you have a lot of rules and it's kind of locked in place. But if you don't need all that, then there's other options.
Well, and I think I said this the last time we were discussing it, but I think the primary problem with all technologies is people kind of pick like they pick a post and they stand by it and they don't move. I think that SQL databases are perfectly capable of most of the things that a NoSQL database can do. Obviously, SQL is just one type of, like I just mentioned, like 7 different types of databases that all have very specific use cases. But as a general purpose database for a user-facing application that has 10, 100,000 users, maybe not, when you get to 10 million users, or maybe when you do. I mean, I'm sure that people scale these things out every which way, but I think there's a lot of great arguments for other types of databases once you're approaching 10 million users and that sort of thing. But even at the small scale, before you start getting into really custom architectures, you can choose to not follow the rules of SQL. I think SQL kind of attracts, take this the right way, but a certain type of neuroticism. We all have different neuroticisms, and they're all focused around different, it's different faces, right? It's like, which neuroticism are you? And SQL is very math-based and very exact. And so when you talk to people that are SQL heads and you suggest relaxing constraints and denormalizing the database, denormalizing basically just means don't follow the rules, they get in a huff. And so if every time you approach a SQL person with a problem, what you get is, you're an idiot, go to, then you're going to think, oh, SQL databases can't do this. And you go to the NoSQL community and they're like, yeah, come on over here, throw away the constraints, denormalize, it's all good, bro.
Yeah, totally.
But it's I think in large part it is a matter of the avenue of access. If you come to an angry SQL nerd with a problem that they don't like, you'll believe that SQL databases aren't capable of solving that problem. And I think we get the opposite thing too, where NoSQL databases now have indexing and lots of nice features to make them fast and performant that traditionally was associated only with SQL.
Yep. I think you bring up a great point though. Like, I think this is great for like users like of any database, but we're seeing like a huge hybridization. Like traditional SQL databases are becoming more like NoSQL databases, and NoSQL databases are becoming more like SQL databases. Like MongoDB, and we now support ACID transactions and joins. Like there's this middle ground that's starting to happen, which I think is great. Like obviously these data demands are just getting bigger and bigger and bigger, and like we need easier and better, more scalable ways to deal with that. And I think that everyone's kind of building off the top of each other to like make something even better for all of us.
Heaven forbid we find the truth in the middle.
I know. No, I'm going to stick my flag in the ground. I'm sticking here. I'm not listening to anything. Yeah, no, it's yeah, and that's not great, right? Like, I think the best tool to solve a problem is like, it's whatever problem you have, and all of us have different problems and different ways to fix it, and that's okay, right? Like, we shouldn't be bashing other people's tools or languages just because it doesn't fit our use case. It may fit theirs.
Amen.
Yeah.
But I do think that there is an alternative way to look at it, which is, people these days, it's become almost a dirty word to think or to talk about or to think about architecture. It means that you're like kind of this astronaut floating way up in space where we need to fix real world problems. And it's all agile, and we just write a failing test, and then we get it passed, and life's good. But there are certain architectural decisions that you do need to make. And I think one of the architectural decisions that people need to make relatively early in the cycle is what database they're going to be using and how they're going to be structuring this database, and maybe what their schema might be like, unless you tell me different. So like saying like everything's good, pick whatever you want, life's good, it's all good. It's not necessarily the best thing in all circumstances, in all situations.
Yes, absolutely. I totally agree.
Yep. And going back to what I was saying at the beginning, I can attest to this, right? It's like, oh, well, I think it'll work great this way. And then I start throwing data in it. And then I'm like, okay, this is hard. It's hard to figure out what I've got going in. It's hard to figure out what I've got coming out. It's hard to figure out how this associates to that, associates to the other thing. And, and I think if we're talking about database use cases, we could keep going. But I really do want to get into this, like how to design your schema in MongoDB, especially since it makes me laugh every time I say that, because then I'm like, but it's schemaless, right? So
yeah, well, maybe should we start with like kind of, because I'm assuming most people coming to this, if either you're an SQL person coming here, or you've heard of MongoDB or document-based databases, and like you're kind of curious about it. But it might be helpful to start for like just do a high-level overview of what traditional SQL database schema design looks like just like normalization, and then we can start going into like how that compares to a document-based database.
Yeah, that's
cool.
Fair.
Yeah,
start with what I know. I like
exactly. Let's start on a common place. And most people, let's meet people where they're at. You know what I mean? Like You're probably coming from an SQL background. So I guess let's talk about normalization, right? So typically when you're designing a database schema for a SQL database, we talk about normalizing the data. And basically what that means is we're splitting the database into, our tables into separate tables, and we're joining them by foreign keys. And there's like 4 different levels of normalization. I always forget. Typically we do the third
There's
form.
6.
There's
There's
6.
6. The 6th level is every piece of data just goes into one column that always references itself.
I've never seen that in the wild. And
that's not real. That's not real.
And I get it. Like from a math, it's all math based, right? Like, and the question too, you're asking yourself when you're normalizing with an SQL database, it's not like, how am I going to be using this data? You're asking yourself, what data do I have? So it's like for example, I always use the example of like a school schedule. I'm designing a school database. I have students have classes, students have professors, right? But yeah, I probably have like a student table and maybe a professor table. Maybe like we can link them by like a advisor, right? Like this professor is a student's advisor, and we link that with the foreign key.
So I agree that this is how most people think about this.
Yeah.
I don't think this is a good way to think about the problem.
Ooh, all right, let's hear it.
Well, so what you just described is what I call categorical thinking. And this is what we tend to do when we're asked to engage the logic part of our brain. We tend to make this illogical jump to start putting things into buckets or classes or categories.
Yes.
And we forget the use case.
Yes.
So it's not that I think that when you put things into categories, you often will arrive at an optimal solution for general use cases. So if you have no other metric which to guide you, sorting things categorically will yield good results. But I would say if you want to, no matter what type of database, the thing that you should start with is, what are the questions that I'm going to need to ask the database?
Yes.
Because it's more important to know what the data will represent to the person that needs to consume it than it is to ask the question categorically, how do these things go together?
I totally agree. Yes. Well, and the thing too is like, because you have to consider performance, right? Like, because if you're splitting things up unnecessarily and you need to like do joins every single time, right? Like that's expensive and time consuming. It start blocking your operations on your. So like, you're right. Let's start like, can we group things that we need to access often together in a SQL database? That makes so much sense. I wish people would think about that more too. And I think that that's not a thought that really comes up unless you start seeing performance issues in your application, which is honestly fine, right? Like you may want to like restructure, like adjust the schema based on performance hits of your application.
There are tricks you can do that will, with all things, I'd really love to learn how Mongo works in this regard, but there's tricks you can do where either you're going to bloat the size of the database, you're going to increase read time, or you're going to increase write time. Like you're always sacrificing, people talk about databases typically among like the ACID metrics, but that's important for consistency, like perfection consistency or eventual consistency. But when you think about performance, you're either sacrificing read, write, or storage.
Yes.
You're never going to reach a trifecta unless you only write the database ever once, in which case you
probably don't need a database.
Right. But you're sacrificing in one of those areas. And you can do tricks like, if you want your data to remain consistent, you can add foreign keys that on reads you don't check because you don't do a join. So you could duplicate data across multiple tables. Say, put a person's phone number in many different places. Have a phone numbers table that you only ever reference when you put a phone number in, mark it as a foreign key so that you have a relationship that if you ever need to restructure the data, you have an easy way to get to it. But then you don't actually use it or join on it. So the ID of the phone number is the phone number. I don't know if that's a little too low level for talking on a podcast where we don't have a white.
Jumping right in here. No. That's totally right though, right? Like, yeah. And if you have a use case where you don't need to pull that phone number up every single time, like great. That makes so much sense. We just need like a reference to it in case we need it someday.
Well, I'm saying that if the ID of the thing, if it's a true enum, meaning that its ID is represented by its value. Like Matt is not a good enum because there are many instances of people who are named Matt, but they are not the same. However, in the entire world, there is only one phone number that is my phone number. So its ID is its value. That's what I was saying, is that on those cases, you can get optimizations, which are quite often things that, you want to do, like states, phone numbers, things that typically, if you were taught in a classroom, they would tell you, oh, you need to join the state to the country and you need to join the country. They tell you to do all these joins. But in reality, for these things where the ID and the value are synonymous, you don't need to do that. That's what I was saying. I see. Maybe got a little too much into the weeds there.
No, that's awesome.
That's the point I was trying to get at.
Yeah, but you're right. There's always trade-offs, right? Like or indexing. If you add an index, your writes are super fast. You're sacrificing
the other way.
Or your reads are really fast. Your writes get slowed down, right? Because you have to re-index that table every single time you change the database at all. Or another thing you can do with an SQL database is denormalize it, which basically means you remove those tables, keep all that data in a row, so you don't have to do those joins anymore. And you have duplicate data in that database. That's not an anti-pattern, right? So you're increasing the number, you're duplicating data.
You're angering the SQL gods. The thunder is rumbling. The lightning is ready to strike you.
Yeah, no, totally.
No, I agree with you. I'm just saying, like, the things you're saying, SQL heads, man. Woo!
Oh yeah,
don't let them listen to this episode.
I'm gonna get it for this one, I think. But it's an option, right? Like if your joins are slowing, like becoming a bottleneck, like that's a common thing to do. Normalizing, denormalizing our data. Yeah, I guess. Anyone else want to bring anything up about SQL based normalization or schema design before we move on to MongoDB?
You were on a good path. I'd like you to finish your thought before I cut you off.
Oh no, I don't know if I have much else to say about it. I think I just want to bring up the point, right? Like you're used to using tables and columns and joining by foreign keys, and we split up based on the data we have. Not always, right? But we're used to bucketing things, and I think duplicating data is scary for most people coming from an SQL background, which makes sense. It's like you start thinking about like increasing the chances of read-write errors or whatever, right? But like,
well, I think the reason that we don't like to duplicate data is that data becomes quickly inconsistent.
Mm-hmm.
Every place you have the duplicate piece of data means that if you need to change it, you need to know two things. One, that you're changing it in every place that it needs to be changed. And two, that the value is identically representative, meaning that if I'm going to change every single place, let's say that we have my phone number, 1-801-555-5555, right?
Yeah.
If that's in the database, if we were to just do a full table scan and replace every instance of that number, would we in fact only be replacing the instances of my phone number? And intuitively you'd say yes, because obviously only I can have that phone number, except that some places in the database that will be my wife's phone number, and that phone number doesn't change if it's the house phone, for example, right? Or some places in that database, it will be the phone number of the administrator for that group, which perhaps the phone number is, I guess the better example would be if we're going to replace the administrator's phone number, which is my phone number, throughout the database. That's the example where we'd see very clearly, okay, I'm going to go change every place this phone number exists. Well, I just accidentally replaced AJ's phone number for his house and for his wife and for all these other things, when what I intended to change was a specific instance of the phone number that was scoped to be just an administrator phone number.
Totally. Yep. I think if you bring up a good point too about, there's a lot of risks with data. And I think databases are one of the scariest things to deal with, especially like a production database. I think it's the least sexy part of a web application. Like I've never heard anyone come and brag to me about their amazing schema design. You know what I mean? No one, that's not something.
You're not hanging out with the right people, Joe.
I'm not.
I can introduce you to some of those people.
Even my coworkers are like, I've never heard any of them brag about their schema design. But it's so important. Like your business logic's important, and if it gets knocked out or gets changed, right, like deleted, that could be catastrophic for a business or you.
There are beautiful patterns that you can create, no matter which database you're using, but there are things to be proud of. It is largely boring because largely you're just categorically saying fruits are connected to grocery store sales or connected to customers. But there are times when they're beautiful and elegant solutions.
I totally agree with that. All right, cool. Anything else about SQL design? Otherwise, we can jump right into MongoDB. Let's do it. So MongoDB design, this is going to be the most frustrating part. I'm going to come back to this over and over and over again. But I think with SQL database schema design, there's a lot of rules. We have like normalization. There's a lot of like best practices. It's been around for forever. With MongoDB schema design, there's no rules. And I think that freedom can be really great or can lead to really bad decisions. And that's why I think it's important to kind of learn about it. And AJ, you touch on this too. I think the most important thing you could ever consider when you're designing your MongoDB schema is how you're going to be using it. And every application is going to have a different schema design. Honestly, for me too, the most important thing I'm considering is how I'm going to be consuming that data. I'm trying to, in order to keep performance high, I want to keep the data that I'm going to be accessing often grouped together in a single object or document. And stuff that I don't necessarily need every single time, I'm probably going to be putting in a separate collection or a separate document linking those with foreign keys. I also want to touch on a couple misconceptions I think MongoDB has. I think, and this is honestly our fault, but we're a schemaless database. We call ourselves a flexible schema database now. You can actually enforce a schema from a database level. So you can be as flexible or inflexible as you want. If you are like coming from an SQL background and you want to lock that whole thing down, or like you work for a huge bank, awesome, let's lock that schema down. Or if you only want to lock down a couple of key value pairs, maybe keep them a couple more flexible, great. Or if you want to like constrain the number of things you can, like a couple different data types or whatever in a single key, you can totally do that too. But the point is, and then ACID transactions too. So splitting things up, you can also ensure that you're updating multiple documents within a single transaction, and it'll roll it back if any of those fail. So to recap, there's no rules. The only rule is that it's based on whatever you're trying to build, and MongoDB is flexible, and it also supports ACID transactions. Yeah, does that make sense so far? Everyone on the same page so far?
Except the part where you said it supports ACID transactions, because how can you both be scalable and support? First of all, what is ACID? What does that stand for?
I was going to say, I feel like we talked about
that
this.
sounds really cool.
Yeah, I mean, I feel like we talked about this in the last episode.
No, let's recap it.
Yeah, but it's one of those
exactly.
things. It's one of those things that I think you need to define each and every time. I don't think anybody will go back to listen to that entire episode just to hear the definition of ACID.
Go back to 23:16 in the last episode. No, totally. ACID is a psychedelic drug. No, ACID is something we talk a lot about in databases. And ACID stands for atomic, isolated, consistent, and durable. It basically means that every transaction you have in the database is separate and contained. And if you're doing like update, delete, create, delete, update, delete, like all those would be a single transaction. And if any of those fails, it rolls everything back and you're guaranteed the previous state before the transaction. It'll throw an error. It also means durable means that if you turn your database server off and you turn it back on again, your data is not going to disappear. So like something like memcache, where all the data is in memory, right? Like it's all in RAM. And if your computer turns off, your RAM memory is cleared, right? So that's not durable. But
also databases like Redis use caching. So they're only durable to a certain degree. If the database gets turned off at a particular time, bye-bye data.
Yes, absolutely. Yeah, and MongoDB, so like
a commit does not represent saving in Redis.
And by default with MongoDB, if you're updating a single document, that is ACID compliant. But what's new now is you can actually do ACID transactions across sharded clusters with MongoDB. I think that came out like 4.3, which means like if you have data spread out all over the world, you can actually do multiple things in your database, like a couple updates, deletes, creates, whatever, and across a sharded cluster. And if any of those fail, it'll roll back.
So I'm going to give an example of something that is kind of not real, but it is illustrative. So I'm on Amazon. There's a quantity of 4 for a Fubeldenger. And so 5 people come and buy a Fubeldenger.
Yep.
And this is not how Amazon would do it, because this would never work. But it goes and updates the quantity of Fubeldenger table and decrements it every time. One of us is in Asia. The other one is in America. Our local replica is representing to us that the quantity is now 1. We both purchase. We both get an order confirmation.
Right.
Because this is the problem of atomic rights.
Yes.
And there's 2 ways to solve it that I'm aware of. One is that a specific shard is specific to a piece of data, meaning that the person in Asia and me over here, if we want to buy a Fubeldenger, then we actually have to make our HTTP call or our database write specifically to the server that is the server that manages Fubeldengers out of all the Amazon products. And that could work.
Yep.
And another strategy, which is the strategy that Amazon actually employs and the airlines employ and that almost everything employs, is to break ACID compliance and say, well, we're just going to let everybody buy Fubeldengers. And when the database resolves, first write wins in this particular case, and last write gets an email notification saying, we're sorry, there was a problem with your order.
Yes. I love this. Yes, absolutely. Yep.
So how does Mongo solve this problem? Does it do both eventual consistency and the sharded write?
Yes, absolutely. So you can set the level of consistency you want on both reads and writes. So let's say it's the data sharded on a cluster. I only want to read once all the data has been written to all the different clusters. Or like I can only do one, or like, you know what I mean? Or like it'll send a receipt back once it's written to one, or it's been duplicated to all of the backup databases as well. And you bring up an excellent point. The freedom to be able to do that is great because you can really fine tune the application based on what you need. And the payoff you're always making is performance. So I think it's called linear reads, where it's like everything, like I do a read and a write and a read and a read and a read, like, and it all comes in the database in that order, and you're guaranteed to get that data. Like, it's going to be correct 100% of the time, but it's super slow. And Amazon's decided that they're willing to sacrifice some of that. They want higher performance.
Well, you can, if you do the sharding, then your write locks scale with your number of shards. So for certain applications, like I mentioned the example of, you find the specific shard that is responsible for that specific data set.
Right.
But you're not going to get as much performance as if you say, we're going to let things flow in and then reorganize them and then resolve errors.
Totally. Yep. I was thinking,
So
like,
I want to chime in here for a second. You guys have totally convinced me just to hire a DBA.
it gets so complicated, especially when you start talking about
feels
scaling.
like it.
Woo.
Right? I mean, it feels like there are, a zillion things that I have to understand. You and AJ going back and forth, half this stuff is going over my head. The other half of the stuff I've played with to some degree.
Yeah.
But yeah, I mean, do I have to understand all this stuff with ACID and sharding and everything else?
Yes. Well, so with MongoDB, honestly, if you're deploying your own databases, yes, you do. That sucks. However, we have a new cloud option, Atlas, that we basically manage all this for you. We also have like a bunch of machine learning stuff happening on the back end, giving you advice for what's going to work best. Like, we call it Performance Advisor. It's like, hey, we see you accessing this thing a lot, or people in China are accessing this data a lot. Maybe you want to geo shard that data so it's closer to them, or we'll auto scale it up and auto back it up. And you just like are in the GUI, you're just setting the level of read write consistency you want.
Before you continue, I have to interrupt. It's a thing that kind of annoys me about this sort of a discussion where I understand that we all are under pressure and we all need to get things done. But the assumption that if understanding and knowledge is required, then it's somehow bad is not acceptable to me. I mean, some decisions have consequences. And if you're going to make these decisions, you're going to require some basic knowledge. Yeah. So if the database that you're building, it has to have like really great performance, or you're committed, you have some SLA requirements for consistencies and whatnot, then yes, you may need to get a DBA, either that, or maybe you need to become a DBA yourself in order to come to the appropriate decisions. Yeah. Now, it's really great if Mongo is able in certain situations where the customer is acceptable to be more lenient or not so precise, and you're kind of able to walk this person through the process. But some complexity is essential complexity. That's what I'm trying to say.
Yeah. Well, just these massive distributed problems are fairly new for us. Like, I think, or at least like a lot of us dealing with it. And I feel like a lot of the tools we have in the market today are like still hard to learn. Kubernetes to me is a super difficult concept to like grok. You know what I mean? Like, distributed problems are super hard. And what you're talking about, like scaling massively, like setting up a single MongoDB database, awesome. I think it's super easy to learn. You're just throwing in some data, and it's this way we think about. But like, I haven't seen a database be able to massively scale without like being able to master it.
Are you stuck trying to figure out how to get to the next stage of your developer career? Maybe you're just not advancing fast enough in the job you're in, or you're trying to break in the first place, or for whatever reason, you keep going to interviews and it's just not working. You want to land that dream coding job, but it just doesn't seem to be working out. Well, John Sonmez has written a book for you called The Complete Software Developer's Career Guide. He walks through each stage of the development career and all of the things that you need to do in order to move up, keep learning, keep growing, and find that next job that's going to get you where you want to go. So if you're stuck and trying to figure this stuff out, go pick up The Complete Software Developer's Career Guide. It's the #1 software development book on Amazon. It's sold over 100,000 copies so far. I actually have friends of mine that reach out to me and go, hey, do you know this John Sonmez guy? Because his book is awesome. So go get the book. You can get it at devchat.tv/complete guide. That's devchat.tv/complete guide. Right. I guess that's what I'm driving at too, though, is that, I mean, if I'm doing the massive scale, if I'm going to be throwing, millions and millions of records into it,
right,
then it's a different conversation. If I'm just setting this up for my,
millions of
reasonably
records would be
small
a small
app,
database.
Or whatever it is. But, that's a big one. Yeah.
Millions of records is a few thousand people on a chat app.
Yes. Fair enough.
To give that.
But all I'm
maybe
saying
200.
is if we're talking about hundreds of big gigabytes of data that I have to munch through,
yes,
it's a different story than if it's hey, I just want to set up this small app that keeps track of these handful of things that and I've struggled with the schema just at those levels.
Yes.
And so I guess what I'm driving at is, okay, are there gradations to this, right? Where if I'm just building a smaller app, it's like, look, make sure you're doing these handful of things and then you're good, right? And then when you scale, you're set up well to be able to do these handful of things. And then when you get really big, then you're right.
I'm going to argue that when you scale, you need to have a DBA. I think you need to not worry about scale until you scale. Fair. And then when you scale, you need to worry about scale. Because if you're designing your app for scale, you're going to waste too much time. And if you
just destroyed the dream of so many startups all over the world. Like, I'm planning my startup to scale to 10 trillion users from day one.
If only there were 10 trillion users. Joe, are you raising your hand?
I am. I don't know how to do it on Zoom calls.
He's being so polite. You need to let Joe go.
I thought maybe like you had like one of those tingles and you were just raising your arm to get blood flow.
No, I do have that too, but I also was just trying to jump in.
You're the first guest. You should totally go.
No one on the podcast can see me raise my hand, but I love that. Well, I just want to say, so AJ, I think that stuff's like totally valid. Maybe we should focus just on like a beginner use case too for people. Yeah. And I do want to say, because like most people don't care about scalability. Like honestly, when I'm making a web application, all I want to do is put data in there and I want to safely get it back. I think that's what most people care about. You know what I mean? Like I don't want to have to worry about
expose it to the public internet. That's a bonus.
Yeah, it's a bonus.
Most people don't care about that at first, but it usually comes to bite you once you get beyond 1,000 users.
No, I totally agree. I mean, I think that's why Firebase is so successful too. They just like, you put data in, you get it out, right? Like, and I think Atlas, we're trying to get there too. Also, can I make a wild speculation that's gonna be really embarrassing in 5 years about the future of databases? I think that a lot of this is going to be manual or like automatically handled for us in the future. Right now, like it's still complicated and we're not good at it, but I think machine learning models are going to get better at auto scaling, auto managing our databases. You know what I mean? Like picking up things that's the dream. I'm seeing it go that way. I'm like, because no one has to worry about this stuff. Just like have a computer manage your data for you and make sure it stays fast and bring it back up again if it fails.
I agree. And when you look at, it sounds like you're already doing this with Atlas based on what you just said. But Postgres calls their machine learning the query planner. It basically looks at data coming in and out, recognizes patterns, and then says, "Oh, you're doing this type of thing. I'm going to start treating the data this way."
Yes.
Like based on how large a data set is, it will decide to rewrite your joins to fit what it knows about your data from being the database. It sounds like Atlas is doing the same thing.
Yeah, that's really what we want. I don't know. No one takes joy in having to design schema for a production database. That's a scary, dangerous thing to do. But if it can be automatically handled, that's
and it's a perfect use case for machine learning because it's all data that the system that manages the data knows both what the data is and how it's being used heuristically.
Exactly. And I'm sure you've seen this too, but like I find that the tools that succeed in tech are the ones that are easiest for developers to use. And I get it, right? Like asking developers to understand like massive distributed computing problems to make a database is a lot of work. No one wants to do that. I don't want to do that, you know?
Plenty of people want to do that, Joe. Can they do it well?
Well, it's a lot of money.
Anyway, you're talking about the basic use case.
Yes, absolutely.
For like the simple app.
Yeah. Let's see here. Okay, so with this, let's get back to schema design here. It's actually pretty easy. There's two things you can do with a MongoDB database, and everything we do is built on these. You can either embed it within a document or you can reference it. That's it, right? And similar thing with a SQL
You can either put it in the row or you can join it.
Exactly. It's the same deal. And I think you have a little bit more flexibility on your structure because you're using a document, right? Or like an object. So you can do an array or whatever. There's lots of different things you can do with it. But the question you should always be asking yourself is, should I be embedding this data or do I need to reference it somewhere else? And again, that comes down to what your data looks like. I'm thinking, should we just start with like some simple examples? And I want to get more complicated. We can kind of do more complex schema examples. Is that cool?
Do the simple.
All right. let's say, okay, 1-to-1, right? Like I think this, we'll just go through these. I think we have like 1-to-1, 1-to-few, right? And we typically think about those with SQL too. But like a 1-to-1 example would be like, I have a user document and my user has a name, right? And so we just have a key value pair that saves that data. Pretty simple, right? We're on the same page there. You're just using key value pairs. You could do, I don't know, address or city or whatever, right? Like just a simple key value pair. 1-to-few, right? We have arrays or nested objects within there. So let's say I have several addresses. Maybe I'm saving my work address, my home address, and my lake home or whatever. You know what I mean? You'd save that in an array. The key to what I'm thinking is like you want to embed the data within the document. My default is embed it. My default's embed it unless I have a compelling reason not to reference it within that object.
From the perspective of, let's say I'm scaling my app and I've hired my MongoDB.
Yeah.
I would imagine it's probably simpler in Mongo than it is in a typical SQL database to create a new schema that will transition things from embedded to referenced.
Absolutely.
Is that assumption correct?
No, totally. Yeah, you just like could do those joins and add that to the document. You just update all those. Yeah, absolutely. So it's like for example too with the addresses, right? Maybe I have an array of addresses. If I wanted to access that data every single time I was making a query to the user table, I would probably embed that. But I might pull that out if I didn't need that every single time, or I had another collection that was going to be using that more often or something. I would probably move that into a separate database.
Can it do, so under the hood, is it JSON strings which is document style?
Yep.
Or is it optimized in such a way that I could pull particular columns out of a row so that I could get both the advantage of embedding lots of things and also the advantage of not having the performance hit of only needing a few things out of the full embed?
Yeah, oh, absolutely. Yeah, you can for sure do that. Yeah, so it's MongoDB documents are BSON, which MongoDB actually supports that or like runs that standard for. But yeah, so you have different data types you'd be saving for that too. Yeah, so you can get kind of tricky too with how you're like sharing or saving the data. Let's see here. Let's do.
And one other thing, you made a new vocabulary term that didn't exist before, or probably does exist in the Mongo community. But 1-to-few.
Yes.
1-to-one, 1-to-many, and 1-to-few. So bounded sets.
Yes. Yep. Absolutely. Yeah. So 1-to-few would be like, so with MongoDB, there's a 16 megabyte limit per document. And 1-to-few, you have like addresses. A person probably doesn't have 16 megabytes of addresses they're going to be adding to this array. So we're probably safe.
And they're probably not shared by anyone else, or when they do, it doesn't matter.
Exactly.
So referential, being able to do analytics on a particular address is not useful or meaningful.
Yep. But for example, like a 1-to-many, where like you have lots of things in there. So I use the example of like, let's say you're in Amazon and you have a product and you want to keep track of all of the subparts. Like I have N64 screw and a foobar chunk. You know what I mean? Like you may have thousands of parts per thing. Maybe you want to do it for like warranties or assembly instructions or for whatever. But in that case,
people that have purchased a product or number of products that people purchase.
Absolutely.
Unbounded sets.
Yes. Yeah, and that's where you like start getting to like dangerous territory. Plus, with this product thing, if I'm making an e-commerce store like Amazon, I probably like when someone hits my product page to view it, they probably don't need to see a gigantic list of parts every single time they view that list. So it's going to be wasted bandwidth sending that data back and forth. So I need a reference to that for that product, but it's not important that I actually have all that information every single time that page gets loaded. So if I'm designing that schema, that's a flag to me that I probably want to reference that data. Because if I'm not using that data all the time, let's split it up. Let's not access it every time. What a waste, you know?
So 1-to-one, the object itself. 1-to-few, bounded sets of related data about the object that probably doesn't need to be queried or analyzed in a meaningful way. 1-to-many, unbounded sets of relationships between two objects.
Yes, absolutely. And actually, there's another one too. So 1-to-squillions, we call it. That's
excuse me?
Yeah. That's like even bigger. So we have 1-to-many. Like we have parts. Like so, we have the parts. There could be thousands of parts. 1-to-squillions is like I use the example of a server log. So like servers, we're writing all of our logs to a MongoDB database, and we have an unbounded massive data set that could be sending to that data or to that database, like for that server for that log. We call that 1-to-squillions.
So this would be the use cases, things that I'm probably not going to search on frequently for that.
Yeah, absolutely. And we want to be mindful of the size of it. I do something. So if I was designing a log system like this, I would do something a little bit different.
How do you spell squillions?
Squillions. Okay. I think it's a made up word. I think I just made that up.
It has an S, a Q, and an L in it.
Oh, that's true. Ooh, I like that. But if I was designing this log system, what I would probably do with my schema is I would have a single document that kept track of some metadata for my server. So this is like server, I don't know, S3, or I don't know, it's Chewbacca 1. I know we're calling it Star Wars, our server Star Wars characters. But each log then, instead of keeping a reference each log within that document as like an array, because that's going to get huge, right? What I would do is every single time I make a new log, I'm creating a new document and I'm linking the foreign key of the server metadata into that log data. So we don't have to worry about it at all. It's easy to make queries on that, super easy, and there's no embedding. So if we're comparing that to the one-to-many, where we have all the product parts, I'm still referencing an array of those product parts in that document. This time, I'm not referencing those at all. My logs are responsible for keeping track of which server it's actually connected to. Does that make sense?
That does make sense. Okay.
Because it's, right, like even a reference can start to get huge. That I'm not like.
We should ask someone else if that makes sense. It makes sense to me. I might be the wrong person to be answering that question.
So I said there's no rules, and I see the irony in this, but I do have some general rules to follow. And if you have an unbounded array, that's a key that you want to reference and maybe split that data up.
Okay.
So let's review the rules again. Then so the first one, we talked about one-to-one, just embedding that in there. And my first rule is prefer embedding. And we talked about one-to-few, right? We have like the list of addresses, right? We just want to keep that inside of there. And then we talked about one-to-many with the product with all of the product parts in there. It's a nested array of all those product parts. We probably don't need all that data all the time, so we can reference those. Like all the data about that product via a separate document we're linking in there. And my next rule then is to avoid joins because they're expensive and slow unless you have a compelling reason to actually do it, right? And we talked about splitting that product part up. And then we talked about one-to-squillions where it's even bigger. We have a totally unbounded. It's going to keep going. Server logs can get crazy, right? And we're doing like a reverse reference to the host. So how are we doing?
One question asked this earlier, but I wasn't very precise in it, and I wanted to get a little more clarity. So if I was going to adjust relationships in a SQL database, pretty much with very few exceptions, the easiest way to adjust that is going to be for me to use a programming language like Node or Go, and to iterate over all of the affected rows and to manually make the copies or the data exchange. I might do it in a transaction, so I might bulk them.
Yep.
But I'm going to write some sort of code that is fetching and making writes in the code that I write, because there's nothing that I know of where you can say, here's the schema, here's a migration for the schema, and the database to be able to interpret that migration.
Yes.
With Mongo, do I have to follow the same approach where in my code, I have to handle the migration as code? Or does Mongo have a way where I can publish, say, this is version 1 of the schema, here's version 1.1, and have annotations in that so that Mongo would know how to update the schema without me having to go and update everything?
We currently don't have a migration tool, but you've touched on a pattern, actually. You can version your documents. And I would typically just do that as a key value pair. So like V1.1 or whatever, to kind of keep track of where things are or what needs to be updated. But you still have to write the code.
So for performance, what I could do in that case, if I didn't care about everything getting done at the same time and I didn't have, I guess even if I had analytics that relied on it, they could still follow this pattern. In front of my read method, or rather behind my read method, I could add something that checks the document. And if it's an old document, rewrites it on the fly as it's being pulled out.
You totally could do that. Absolutely. Yeah.
Okay.
And it depends on like what you want to do with it too. If you just want to like overnight run a migration that updates your schema or whatever, that's totally fine too. But yeah, you could totally do that. Absolutely. You have the control to do that if that was something that made sense for your application. I do want to go over one other one, which I think is good to go over with MongoDB schema. I feel like if I talk about schema, people we get too far into the weeds, people's eyes start to glaze over. But I do think it's helpful to touch on something that's more concrete to help kind of understand it.
Well, with what Dan said, I think that we kind of need to be a little less resistant to that type of mentality. Like if you're being paid to be an engineer, you are being paid to use your brain.
Yeah, no, totally.
And using your brain is sometimes, requires understanding things that which were not intuitive to you before.
Yeah, no, it's true.
I agree. The only point that I was trying to make at that time was that there are some things that I need to worry about right now and some things that I don't.
Yeah.
And so what I wanted to know was what things do I need to worry about right now and what things can I put off until I realize that I'm heading into a place where I need to care about the other things.
Yeah. And I think that's our job, right? Like there's a lot of things we can do. There's always phase 2 to work on.
I have a giant pile of problems to solve.
Exactly. Yeah. And
if y'all could use the word thing a little bit more often in that conversation, I think it'd be even less understandable.
Yeah. Is this too abstract? I don't think so.
So there's a thing, and when I need to know the thing, then if the other things matter, that time the thing I need the thing will thing it.
You guys do a great job with this, actually. Like, I think it's so hard to describe technical concepts in a podcast. You can't
it is.
I can't point to a board on it, right? That's hard to see. Everyone's trying to visualize this in their heads. But I think you guys do a great job of that.
I'm just teasing you, just so you know.
Yeah. And really what I'm looking at is, I mean, I have a big pile of stuff that my boss wants me to get done.
Yeah.
So what's the minimum viable amount of knowledge that I have to have in order to do my job? And then is there like a framework or some system that I can use so that, okay, now you're starting to see this, go solve and learn this other thing before it becomes a big problem for you?
Can I give my personal opinion on this that is not substantiated by any facts?
You did not raise your hand long enough. Please raise your hand for addition.
Beyond's at home. I am raising my hand every time. I learned a lot in school, but my opinion on that is like, you want to get it working, and if it starts breaking, then figure it out. And even with databases, like, you know,
that's what, like, programming 101.
Exactly. Yeah,
it is.
Just throw it in a database. Honestly, like, and this is my personal opinion, but like, just throw it in a database, and if you start seeing performance hits on it, time to come back and time to like rethink your schema, rethink your scalability.
Yep.
If it ain't broke, don't fix it. You know what I mean? Also, like right now, like with databases, like if it starts slowing down, you could there's easy quick fixes. You could throw an index on it, you can shard it, you can spin up more servers. Like you can pay money to kind of delay that. But you know, but if just get it working. Even people are in here today, like if you don't grok everything I'm talking about here today, don't worry about it. I still recommend just make crummy database, make some mistakes, iterate and grow. You know, that's okay. That's totally okay.
Amen.
Yeah. I want people to make more stupid stuff that sucks. That's the way that we learn.
I feel so mixed about that. I feel so mixed about that.
Let's talk about it.
It's so true. No. It's so true. It's so true, but it's frustrating when you walk into that. Like,
I know.
When you're the DBA that gets hired on for the app that is now approaching 10,000, 100,000 users, hurts. I mean, I haven't been in that situation personally as a DBA, but just saying, like, it's the double-sided sword. Like, if you don't do the stupid way, you'll never learn. And if you do the stupid way, at some point you got to go back and, well, if you're lucky, you have to go back and fix it.
And that's been a criticism of MongoDB too. It's like, it's so easy to learn. Beginners can pick it up and mess it up. Totally reasonable too. But yeah, it's also easy to fix too. And I don't know, I feel like it's really gatekeepy to insist you have a database that's really hard to learn because newbies won't be able to touch it. I think that sucks.
I think one of the most difficult things about databases is the differences that don't matter. You know, the things that are frustrating are not SQL itself. You know, being able to do a couple of joins, that's not frustrating. Being able to understand JSON, that's not frustrating. What's frustrating is that, you know, in Postgres, if you want to describe a table to figure out what the heck you did, it's /D. But if you want to do it in MySQL, it's describe tables. But if you want to do it in MS SQL, it's show table description. And if you, like, I don't know if that's actually it. I'm getting some of these wrong. But it's like, and if you want to do it in Mongo, there's some way to do it in Mongo. If you want to do it in Couch, I think the frustrating part is like all the little tiny 1,000 paper cuts that are actually not important to the data. The actual structuring the data, I don't find that to be the hard part. You know, that's not where I mean, it's where you rack your brain because you're like, let me think about this and make a good solution. But it's not like where you're stuck in, you know, pages and pages of documentation trying to figure out an example that actually does the thing that should be obvious that you want to do.
Yep. Can I talk about another concrete use case? Actually, so the first time I was on this podcast, I was talking about my IoT kitty litter box, and I used a MongoDB database for that. And I like this example because it's kind of goofy, but I also think it's easy to understand. But when I designed the database schema for that data, for my IoT kitty litter box, the main thing I was thinking about was how I was using that data. And what I was using it for was I built a dashboard that displayed the number of times my cat went to the bathroom per day. So I started thinking about my schema in terms of like, how do I design the schema that I can just, that data is ready to go. And so what it did, it's a pattern we invented called bucket pattern. And every single day it creates a brand new document in a database. And it's a one to few or one to many. Because my cat's probably not going to go to the bathroom equivalent to 16 megabytes times. It's probably, 3 to 5 maybe. But so I just have an array and I'm adding a new document every single time using the box with a timestamp. And then I just make a query and it's super easy to throw on a graph. It's in the structure, or I already need it. Does that make sense? Like every example is different and how you're using that and what kind of performance you need affects how you access and design the schema for that application.
So Amy had a question on analytics. This is totally like throwing this thing off the rails, but I feel like we're at a good point.
I love rails
and time is running, so I want to make sure Amy hasn't been raising her hand.
That's fine. It's because I have my camera off. Are you sure now's a good time though?
Let's do it. We're
I was going to say her photograph has not moved this entire time.
I always turn it off because I don't know. I don't know. I feel funny, like people watching me. Anyways, yeah. So my question was like, I feel like more and more companies are doing different stuff with just, you know, the amount of data they have and stuff like that. And like one of the popular things I've seen with MongoDB is people will like take the data in MongoDB, and if they want to put it somewhere for like analytics rather than using MongoDB or something like that, they'll like do an ETL, extract, transform, load into BigQuery or something like that. So I guess my question is, in your opinion, is that still the best bet, or is that something that like MongoDB is looking to keep, you know, like in-house so that you can use like a MongoDB solution? Or is the recommendation still to just like move it into like a data warehousing tool?
It totally depends. Like classic answer. It depends. I mean, we obviously support the tools to do data analytics. So if you want to like once an hour or whatever, you have a separate database that just goes and runs some aggregate queries and kind of repopulates your database or whatever. That's totally possible, totally fine. But yeah, if you have like another tool that you want to throw that into, cool, you can totally export that out. Or some people use MongoDB as their data analytics tool. They'll save their data on an SQL database and then just have that run analytics queries in the background. Yeah, I don't know. It depends.
What type of analytics, Amy? What type of analytics?
Yeah, I mean, I guess like to me, I guess for like the stuff that I'm thinking of, it's a lot of data. So I feel like it would probably be better in something like BigQuery, which is Google's.
What's a lot?
In this case,
petabytes,
I'm talking
terabytes.
Oh yeah. Petabytes, like you know. So
and it might be. It might be.
I can't imagine Mongo being a good tool for petabytes of data.
Yeah, so that's why I'm saying like
that's not to knock on Mongo, but that's a very different problem.
Yes, well, that's why I'm like wondering, is that something like MongoDB is looking to solve? Are they just like not interested in solving that kind of problem? Because
absolutely. I mean, I'm sure anywhere there's a chance for us to get more people to save data on our database would be a win for us too.
But petabytes, man?
That's a lot, yeah.
Petabytes?
And it's hard to tell. So
do you have petabyte customers right now? Can you like?
We do. I can't say who they are.
Well, that's fine, but you do have petabyte customers.
Yes, we do. Okay. Yeah, it depends. It's hard. Like that's what comes down to like performance, and I feel like performance is a tricky thing. And the only way to tell if there's like what's going to be more performant is to like test it. But yeah, maybe you're indexing on the right things, or you're aggregating at the right. I don't know. It depends. We are
makes sense.
Right now. To what we're doing is trying to move the MongoDB query language into more areas. So like we just unveiled this thing. You can now query Amazon S3 data, or you can use like S3 buckets, and we can query those with MongoDB. So you can like archive mass amounts of data, and we call it MQL, or the MongoDB query language, to actually use it. Because we're seeing that like the industry now is starting to adopt the query language because it's so intuitive for devs, right? Using like dot notation to kind of
it really is
build queries.
I mean, that's one of the things I like about it. It's so easy to learn.
It's because it's like you're writing it and saving it the way we think. Cool.
As a JavaScript developer, it feels very JavaScripty.
Exactly. Yeah. So we're trying to move that in more areas, which I think is kind of cool. Because we talk about this too. Like learning new stuff sucks. You know, I have a limited amount of time. I can't learn much stuff. I already know MongoDB. I want to use that to make as many queries as I possibly can in as many different areas as I can. Yeah, analytics.
This is an area of interest for me too, because I've been wanting to build my own podcast statistics analytics system, right? Because the ones that are out there all suck. I'm sorry. I have friends that work at those companies. They suck.
Totally. Yeah, or like just a custom solution. That makes total sense. Yeah, absolutely. Yeah, no, I totally agree. Especially if you're building something, I think MongoDB, obviously, it's an easy way to like, get it set up. You can start solidifying that schema, growing it, scaling it, whatever you need to do. But I'm obviously biased, but I think it could totally work. But it depends. It may not always be the best solution.
Well, thank you.
Yeah. I guess any other questions about schema design? Do we get too deep? Should we do a quick recap here? Do we want to?
Yeah, we got to do it fast. I have a hard stop in 15 minutes, but
Yeah. Okay, cool. I'll just do let's do a TLDR. I'll probably forget something here, but MongoDB schema design, there's no rules. And basically you have two ways to handle MongoDB schema design, either embedding it within the document or referencing it. And some considerations you want to make when you're designing your schema is like how and where you want to save your data. You want to provide a good query performance, and you probably don't want to use an unreasonable amount of hardware to build your application out. Like we want to try to keep our data costs as low as possible, right? But yeah, we talked about one-to-one. So that's just like one user and maybe, or like an employee and how they work in one department. So that'd just be an embedded document. We talked about one to few. So it'd only be like a handful of things on there. And we talked about like embedding that in the document as an array. Then we talked about one to many. And that's where we started talking about actually splitting that data up into references or joins. So into separate documents or separate collections, and you're joining those with a reference. And we use the example of a product and keeping track of all those parts as references in there. So you probably don't need that data every single time. And then lastly, we talked about one to squillions, which we talked about that even bigger, more massive data that you're saving, right? Like a log system for a server farm. Do you just keep them?
To be clear, you made up that term, or that's a term that Mongo uses?
MongoDB uses it. Yeah.
Okay.
MongoDB uses it. Yeah. I stole it. Thank you. Give credit to my corporate overlords. But we use embedding references.
Did you say overlords? You meant protectors.
Protectors, that's right. Yeah, my dearest protectors employer. There's a bunch of other ways to do it too, which we didn't talk about today, like tree structures or graph structures, many-to-many relationships, like a to-do list with lots of users that have lots of different shared to-do lists. Right? There's lots. We didn't even discuss those today too, but those are the basics of MongoDB scheme design. Any questions? Anything I left out? We talked about how start easy, build it till it breaks. Distributed systems are really hard. Don't worry about it too much until you need to worry about it, or hire someone that needs to worry about it. Again, personal opinion, but I don't know. I'm a big fan of just building it, just build it and then fix it once it breaks.
Are you freelancing or moonlighting? Or maybe you've thought about going out on your own? Every week, we have a group of developers at various stages of the freelancing journey on the Freelancer Show to talk about becoming better at freelancing. We also bring in experts to talk about marketing, SEO, and delivering high quality to clients. So if you're interested in going freelance or you are freelance, check it out at freelancershow.com.
Well, I'm going to push us to picks because, like I said, I've got to jump off in about 12 minutes.
Love it.
Steve, do you want to start us with picks?
Yeah, I've been talking too much, so I haven't had a chance to think about anything.
Welcome back, Steve.
I've just been overwhelmed with the depth of knowledge of AJ and Joe and everybody, But seriously.
You flatter.
No, today, so I've been trying to find a pick here, and I'm going to go with a good joke that I found today because I never tell jokes anywhere else on the podcast. So one of the favorite tweets that I've seen referenced over the past year or so is the Flat Earth Society and talking about how they had members all around the globe. And so the new one I saw today was the COVID-19 has really been stressing out the Flat Earth Society because they're stressed that all the social distancing is going to push their people over the edge. So
you get one laugh. That's great.
I will not claim that I wrote that myself. I borrowed it. Let's just say I borrowed it.
I have to say I did chuckle when I saw it on Twitter, even though you didn't get the full effect here because you'd already shared that.
Well, I got a laugh from Joe, so that I got something.
It counts. I didn't even get a single sharding joke in today. I'm disappointed in myself. At least you're bringing the jokes. Yeah, dang it.
I feel like sharding jokes are inevitably going to be potty jokes.
It's the only one. It's the only one. It's the only one.
Yeah, that was my thought too.
That's where my brain went.
Yeah, that's the only place. But Steve, thanks for bringing the jokes, bringing the humor to the podcast.
Anytime.
Absolutely. Amy, what are your picks?
I'm going to go with, let's see. It's been a while since I did a non-technical pick, so I'm going to go with that. I bought on Amazon, which I've been wanting to buy for a long time. I don't know if it's just quarantine and sitting too much and not working out like I used to, but my back has just been just so cramped up to the point where I feel like I can't even focus most days. And I'm just every hour on my foam roller trying to roll it out so I can keep focusing. But I bought an acupuncture mat and it is very painful to lay on at first, but eventually you get used to it. It's only $20 and I feel like it's helping. My back is you can literally see these punctures in it when you get up off of it, but it's helping. And so that's gonna be my pick. Wow. I see Chuck Googling.
I know. I'm going to have to check it out for my wife. We've been trying to find ways to reduce her pain. So
yeah, I mean, it's like in like my traps, and there's like a little pillow. So I've been like leaning on the pillow thing, and it's not real. They call it an acupuncture mat. It's not really acupuncture, but it's supposed to like increase blood flow just because it's kind of like has these little baby spikes that go into your back. But I do feel like it's helping a little bit.
Boy, they got all kinds of stuff. Put a link into the one you bought and I'll
Will do.
All right. AJ, what are your picks?
Let me unmute here. Okay, so I found an article of SQL versus NoSQL when I was searching during the podcast here. I was looking for something about big data, and then this popped up, and it seemed to have like a pretty good breakdown of different use cases and whatnot. So I'm putting a link in there to that because I think that it is actually a pretty decent article. I'm also going to pick Jonathan Colton of so much fame. Oh my goodness. Such a great musician, bringing you just all sorts of nerdy nonsense, and particularly Chiron Beta Prime, which is what I was making reference to earlier. Did I say overlords? I meant protectors. So if you're stuck on Chiron Beta Prime and you need to send your relatives a Christmas card, just send them that link instead. I am also going to spout out about a tool that I created called SSH PubKey. Very, very simple thing. I've got the cheat sheet up on webinstall.dev. And basically, you have these times, and this works on Windows too. This works on Windows also. So that's important to note. But you have those times when you just want to grab your public key pretty quick and you might be on a new machine. And it's not that it's hard. It's just that there's like 3 or 4 steps. And I just wanted a single command that creates the key pair if it doesn't exist, prints the public key to the screen, and puts the public key in the downloads folder because, like, for example, if you're using Amazon, you can't copy and paste it. You have to upload it, and then you need it to have a name that makes sense. So it copies it into the downloads folder as the username.ssh.pub or whatever, which is important because otherwise on Amazon, you end up with like 6 different keys that are called IDRSA, and then you don't know which one it is. And it's also hard to navigate to the hidden.ssh folder from Finder and similar. So anyway, just a little utility for those of you that understand the problem. You understand the problem. For those of you that don't, you don't. No biggie.
AJ, that's awesome.
Thank you. There's some other stuff on there you might like too. If you look at webinstall.dev, if you've got any suggestions, let me know.
Cool.
Speaking both specifically to Joe as well as anybody listening.
The audience, yeah.
And then I am going to pick the same thing that I picked last time that Joe was on here, which is the Ars Technica war story. I have to go find the link again, but I'll post it again, in which the guy who coined the term sharding, which had to do with magical shards, I think is what it was. Like the kingdom was governed by shards. Some game. It was the first massive multi-online player game that required databases. Well, maybe not the first that required them to be sharded, but the first in which the term became popularized. And the interview is just, the war stories are, the Ars Technica war stories are just amazing. I highly recommend, if you listen to this podcast, you would absolutely love watching the war story video interviews.
And confirm, they're great. They're really fun to watch. And like very accessible.
Yeah,
awesome.
Yeah. They're high production values, so they tease the questions and the answers probably a little better than we do. The 10-minute versions are super digestible, and the full hour versions are so amazing.
Cool. I'm going to jump in here with a few picks. One pick that I have, and this is a book I'm reading right now. It's called Leadership in Turbulent Times. And I can't remember the author's name, but I'll put a link to it in the show notes. It's been an interesting read. And she goes through and talks about 4 different U.S. presidents and some of the turbulent stuff that they went through. One of them is Abraham Lincoln. I'm trying to remember the other ones.
And Doris Goodwin's the author. Just looked it up.
Yeah. Yep. And anyway, so it's interesting. I don't necessarily come down politically, agreeing with some of the presidents that she talks about, but they all did go through stuff and exhibited some leadership qualities that are worth emulating. So, sometimes you have to overlook the parts that you don't disagree with to get the gold. And so I'm going to pick that book. And then I kind of want to pick some other stuff, but I'm having trouble remembering what it was I was going to pick.
Too many good stuff.
Yeah. So I'll hold on to it and I'll pick it next time. But yeah, Joe, do you have some picks for us?
I do. I'll go fast here. We're doing a book club at work, but we're reading Stamped from the Beginning by Ibram Kendi, but it's been great. It's been an awesome discussion. It's been a great way to talk about race at work, which has been kind of uncomfortable, but it's been helpful for all of us.
We've been doing that here too. It's kind of cool. They give us recommendations.
Right. And I feel like race is something that we've been told not to bring to work, but obviously it's a big deal right now. So like, I think it's been great. I don't know. And the other thing I want to talk about too is if you're inspired or interested in learning more about data modeling, we actually had a free course on university.mongodb.com. It's M320 data modeling. I'll have a link for that in there as well. That's it for me.
All right. Well, thanks for coming, Joe. If people want to follow you online, where do they find you?
Oh, I'm Joe Karlsson. That's JoeKarlSson, the number 1 on Twitter and also on TikTok. So I'm on there too, but that's just my first and last name. Hit me up on Twitter
for good stuff.
And Instagram. Yeah, same. It's just my first and last name. Amy and I are Instagram friends.
Good videos. Like.
Yeah.
All right. Well, we'll wrap this one up. Until next time, folks. Max out.
Bye.
Bye.
Adios.
Right.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.
The new Chevy Silverado HD puts you in command. Own strength with its enhanced available Duramax 6.6-liter turbo diesel V8. Own the lake with its available advanced towing technology. And own technology with an available 13.4-inch diagonal touchscreen. The new Chevy Silverado HD. Own work, own play, own life. Learn more at Chevy.com. Find new roads. Chevrolet.